Welcome students. This is the topic related to synchronous machines and we will be solving the examples. So let's look at this first example that we have a 200 kVA, 480 volts, 50 hertz, Y connected synchronous generator with a rated field current of 5 ampere. And it was tested and the following data were taken. It was for a particular IF, that is a rated IF. The terminal open circuit voltage was measured to be 540 volts, and for the same rated current, the short circuit current was found to be 300 amperes. So they are the two types of tests that we perform. And when a DC voltage of 10 volts was applied to two of the terminals, a current of this 25 ampere was measured. So what is required is find the values of armature resistance and the approximate synchronous reactance in ohms. So we all know that the synchronous machine is actually, we have the stator, the stationary part, and then we have the rotor that is actually inside the stationary part. This is the rotor, and here it is producing a magnetic field due to IF. Inside the stator we have a three-phase winding, and this three-phase winding is actually, you can say, is we have the three-phase winding inside the stator. Now let's first look at what it's saying, that and why I have connected it. Why? Because it is mentioned that it is a synchronous generator with Y connected windings. Now the first of the tests is what are the voltages. Let's see, they have performed the open circuit test. That means that here are the terminals I call A, B and C. This is A, B and C. Internally it is connected like this. For these three terminals, when the open circuit tests were performed, no load was connected and a voltage was measured. Voltage was measured across two terminals. Okay, so this was the voltage that was measured and it was 540 volts. And for the short circuit test, and this was 540 volts when IF was at its rated value. Now the second thing what they did was they short circuited the terminals. And then they measured the current for the same rated field current, and the current that was measured at that time was IL for line, the current or the terminal current, you can say, that was coming out from terminal A and flowing like this. I have shorted down terminal A and B, and this was actually 300 amperes. So these two tests were performed like this, and the third test that they performed on this device was, what they did was this is being done separately. Okay, the third test that they performed was when they applied a 10 volts DC voltage to the synchronous machine and a current, and they measured the current, how much current flowed through it. So this current actually flowed through this area and coming back, and this was 25 amperes. Now they have given us the results of three tests, and what they want us to determine is, we know that for the per phase equivalent circuit of our generator, synchronous generator, what we have is, we have an armature resistance RA, we have a synchronous reactance JXS, and what is required is that we have to calculate the values, armature resistance and approximate synchronous reactance in ohm ohms for our device. So we can start this. I hope now the question is clear. Let's start with the simple part that is related to RA, and that is armature resistance. So for the armature resistance RA, this data, when a DC voltage of 10 volts was applied, this information will be used because, as I have shown you, they have applied a DC voltage here and a current of 25 amperes flow when a 10 volts DC. Now this current is actually flowing through this area. So as it is DC, inductance is no value, but this is actually due to the resistance. This is the circuit. So now if this is the circuit, we can see that RA and RA comes 2 times in the path of the current. This is actually a simple circuit, DC circuit with RA and RA. This is VDC. This circuit is actually like this. So we can write this as 2RA equals to VDC over IDC. And VDC they have given 10 and IDC is 25 ampere. So we can calculate the value. This will actually become VDC is 10 volts and the value of IDC is 25 amperes. And so, and when we multiply this with 2, so the value of RA would be 0.2 ohms. So this is the first part that we have calculated the value of RA. Now for the second part that is related to our calculating the synchronous reactance. Let's look at this. How can we calculate this? So the first thing that we need to do is we have to calculate, as it is a no load condition, V terminal open circuit. We have to calculate V terminal open circuit. That will be actually in the open circuit, this will be the value for a certain value, and this is actually the same value as this value for the open circuit. Now as we can see in the circuit, they have given us a value of 540 volts, but this is not per phase value. This is from line to line voltage. This is line to line voltage calculated between terminal A and terminal B. So the first step would be we have to convert this line voltage to phase voltage. So EA equals to VT, we can call it V phase over circuit, is actually equals to V terminal under root 3, as this is line to line. And this value will then become, we have 540 volts divided by under root 3. So EA, that is the V phase open circuit value, is equals to 311.8 volts. So the first thing that we were able to calculate was this value. And the second thing is related to our short circuit test, and the short circuit test gives us a current was found to be 300 amperes. Now this is the current that is flowing through the line, and we know that in Y connected circuits the phase current is same as the line current. So we can say that it is actually the armature current at short circuit is actually the line current at short circuit, and that is equals to 300 amperes. So we have these two values. Now the overall circuit, we can say for a rated IF, rated value at rated IF, that means at rated field current, the overall circuit of the system can be written as this is Z. Z synchronous is equals to the EA, that is actually the open circuit characteristics from, and IL, that is IA, that is actually from the short circuit characteristics. So this will become the value of so Z synchronous equals to EA over IA, and this is actually V phase open circuit over IA short circuit. And what is Z? Z is actually equals to armature resistance, RA plus JXS and so V phase open circuit over I armature short circuit, or we can write it as the amplitude. For the amplitude, this will be RA square plus XS square equals to 311.8 volts divided by 300 amperes. And if we solve this circuit, and the value of RA we have already calculated 0.2 ohms, so the value of X of S, the synchronous reactance, will become 0.2 ohms. And as during the class it was also pointed out as we were studying this, that there is also a direct formula. Direct formula to calculate X of S is actually when we are able to have the, that is actually the open circuit voltage and the short circuit current. If we have these currents, we can directly calculate X of S. Let's see, does this formula works also. So let's look at equals to 311.8 divided by 300, and we can see that X of S is 1.04 ohms, and there is a very small difference between both the methods, but because the value of armature resistance is usually very low. So in this way we can solve this parameters for our circuit. I hope it helps. Thank you.